Okay, so sorry, something happened, so my session stopped recording, so I now have to do a third video segment, but the rest of the problem is done in the data mapping module. Now, just to make sure that actually I took the right pressure, so let me double click on this, browse. This was the one, right? Triangular one. And show me the bounding box right there. And if you want to see the numbers, here these are the adjustments that I made. Okay, and then I say okay, and run it, because you cannot see the distribution visually here until you run it. That's fine. Now, you can look at the deflection, stresses, and everything. Fine, okay, no problem. Let me get rid of this, deactivate that. What I do want to see is the pressure distribution. Remember, the way it's supposed to be starts at 20, drops down to 0, and stays 0 for the rest of the structure. So let's visualize this. So put it on the pressure, right click, pressure visualization on the mesh, and there we are. You can see that 17.5, because over here it was 20, over here it was 15. This one is 12 and a half, 12 and a half, because over here is 15, over here it was, actually not 12 and a half, let's make sure. 7.5, because over here it was 15, over here it was 0, the average is going to be 7.5 right at the centroid, and over there they're going to be 0 pressure, as I expected, because that's what I did. Remember, I did this, okay, this, so now I want to change that so that this is the problem that's done. In other words, start at 20, go to 10, stay at 10. Okay, so let's go ahead. We are going to deactivate this pressure distribution there. So we go there. We have to go and modify our spreadsheet, right? So let me cancel that. Go back to my spreadsheet, which was, I believe, here. Nope. Okay, make the appropriate changes. So 20, then to 15, then to 10, which means a factor of 1, a factor of 1. And then after that, in other words, the last two elements, which are coming from between this and that, the factor should be 1. So 1, 1, 1, 1, 1, and 1. Okay, now I'm going to save this thing. File, save as, browse. I'll say triangular constant. Okay, all right, we save it there, we close that, and we go to our CATIA. So double click on pressure, browse. I want triangular constant, say okay. Show me the bounding box. The bounding box is still here. Show me the table. Remember, I made those things all equal to 1. And okay. Now, when I try to activate this thing, it will tell me that you have to run it, which is fine. Okay, so I can do that, or I can run it from here. There we are. It did run. Okay, so for example, you can see the displacement. Don't let it bother you too much. Select on the amplification factor, make it default, so it's more meaningful scale. Okay, we say okay. Now we put the cursor here, right click, let me see, activate, there. Okay, so let's see what happened here. Remember, it started at 20, it went down to 10, and stayed 10, and there we are, 17.5, 12 and a half, 10, and 10. Okay, so I basically solved this problem, these three problems for you, these three problems for you. But there is a caution. I would like to advise you that when you look at the help documentation in CATIA, you will see something about check that the center of gravity of each entity of the recipient mesh. Recipient mesh is the one that I created, okay? And the bounding box and the source mesh is the thing that I put in the Excel spreadsheet. Basically, it came from another software. There is a tolerance involved. In other words, if the centroid of some element is within that distance of the bounding box, it will use the information in the box to put the pressure at the centroid of that element. So just be aware of the fact that there's a little bit more to what I showed you in than really what it is. If the things that are outside of the bounding box are too close to the bounding box within that kind of a tolerance, then you may get pressure there that is not intended. But in reality, these are all should be all fine meshes. So even though one element is too close to the bounding box, what we did not intended to be there, okay, it's going to put some pressure there, but it's not going to change the overall behavior of the structure. Okay, just be aware of this fact. Okay. Now, last thing I want to show you today, which kind of is related to what I just said, is that let me do the following. Let me go ahead and uh, delete this, okay, and deactivate that. And I want to remind you, here we have 17 and a half, 12 and a half, and then 10, right? Okay. So what I would like to do is actually go ahead and turn these quadrilateral element into a triangular one. And since these were created in the advanced meshing tool, so we have to go back to the advanced meshing tool. And let me get rid of this part. I don't want to see the part. The actual part I don't want to see, so let me hide it. Oops. I want the hide and show. I don't want the part, so maybe I better go here and change and hide it from there. So hide this. Okay, so I just see the mesh. Good. So if you look in here, there is an edit mesh. We are in advanced meshing tool. There is an icon which says edit mesh. I've got to find this. Let me see for a second. Edit mesh. Not there. Not there. Well, let's see whether we can find it through. Where am I reset all the toolbars, Windows, tools, customize, toolbars, store all contents, store all positions. Let me close the things that I don't want. So, see for a second. Oh, yeah, I know what it is. It was there. It's just that you have to go to the surface measure. I think that's where you can see the edit mesh is going to be. So surface measure, maybe not. So let me see. So double click on that. Right. Okay. So I double clicked on my surface mesh here. I'm going to close that. And right here, you see there is an icon which says edit mesh. Right there, edit mesh. Look, I had to go to edit mesh. I was trying to find the icon from the right column. I couldn't, so I double clicked on the surface mesh. it will put me where I'm supposed to be, and there is the edit mesh, right there. Okay, so notice that you can go, let me hide this tree, edit mesh. I can take the cursor there, and the scissor pops up, and it says, okay, do you want to cut it here? Yes. So notice that my quad element suddenly turned into a triangular one. Do I want to cut it there? Yes. This one and that one. And we say okay. And exit the surface mesh. Notice that we no longer have quad elements. We have triangle ones. Okay. So we're done here. So let me get the tree back. There we are. And once we do this, we're going to go to the generative structure analysis. Okay. My part was hiding. Remember, I put in hiding right there. And you can actually see your mesh once again if you want to see that. It's right there. But let me deactivate this for a second. Okay. So if you go to pressure right now, remember it was the triangular one followed by the constant one. So if you see, show me the box first of all. No surprise. Show me the values. This is the last thing that we did. You say okay, and I believe you're going to run it. Okay, so we are repeating that problem, except that the elements are not quad, the triangular one. But I want to show you how the pressure varies. The calculated pressure varies here. So right-click, pressure visualization, and look at what happens. Okay, so remember before it was 17.5 because the centroid of this quad. Now, of course, the centroid of a triangle is somewhere else. So if you look at this, it says it put this value, this pressure at the centroid of the triangle over here, 18.3, okay, and then 16.7. Before it was 17.5 right in the middle. And if you actually find the sum of these two and multiply it by the area of this triangle, you get exactly the same thing that we had if I took the 17.5 multiplied by the area of this quad. But my point is that triangles, because they have different centroids, these two triangles, different centroids, the way the pressure is placed is at the centroid of them. So just be aware of that fact. You may not have nice quad element. You may have a triangular one, and you got to watch out about this. Okay, that's the last thing that I want to show you here. I use the concept of data mapping for pressure defined on surfaces or shell elements. If you have a temperature defined on shell or defined at on a solid element which is non-uniform, then you have to either do data mapping or create the data mapping data from some other external package and import it. Okay, good luck.